Rendering is about turning animal byproducts, ABPs, into derived products by heat application to dehydrate, sterilize, and separate their components into rendered animal fat and processed proteins. According to ABP's risk category, processed proteins are called PAP for category 3 or meat and bone meal, MBM, for high-risk categories 1 and 2. Depending on its risk category, rendered proteins might have different industrial uses, from animal feed to source of chemical industry, as fertilizer or biogas fuel. However, most part of high-risk categories 1 and 2 are currently not being recovered but disposed or incinerated due to current restrictions at European level. Rendered animal proteins have a high content of proteins, approximately 50% in dry weight, being collagen the main protein component, product with a current increasing market demand. This is why the extraction of these proteins as collagen hydrolysates or gelatins for different industrial applications was proposed in the European Pilot ABP project as a suitable way of recovering processed animal proteins, being otherwise waste from the rendering industry. For such purpose, a demonstration pilot plant has been developed for the production of technical-grade biopolymers based on proteins from PAPs. First of all, the extraction process of proteins from PAPs has been optimized at laboratory scale. PAPs used in the project are composed of 45 to 60% protein, 10 to 18% fats, 17 to 37% ashes, and 3–4% humidity. Even though only category 3 meals have been used, the production of protein biopolymers could allow the recovery of category 2 as well. First, pre-treatment with lipases and warm water might be needed in order to remove fats. This step may be skipped when using PAPs obtained by method 5, according to the project results. By centrifugation, the aqueous phase is separated from pre-treated PAPs as effluent, which is characterized by high concentration of organic matter, as well as nitrogen, sulfur, and phosphorus compounds, quite suitable for recovery as fertilizer or biofuel source. After that, the collagen extraction by hydrolysis of the PAPs is carried out using a protease at high temperature. The extension of the hydrolysis step determines the molecular weight of the final biopolymer to obtain gelatin or collagen hydrolysate. Finally, an aqueous solution of the structured biopolymer is obtained. The biopolymer solution is filtered and centrifuged to remove solid particles from bones or unreacted protein fraction, which can be circulated again to the reactor feeding. During the project demonstration phase, the developed process has been validated at the pilot plant, designed and built for such purpose, which has a treatment capacity of 25 kilograms of PAPs per batch. Main parts of the pilot plant are provided with automated management systems for temperature, pH, pressure, mass, time, agitation, etc. At the pilot plant, technical biopolymers have been produced. Depending on the intended application, the biopolymer solution is partially evaporated in the reactor at high temperature and pressure to obtain a concentrated and sterilized liquid product, which is then spray dried to obtain a yellowish powder when this format is required. Obtained biopolymers are suitable for different industrial applications, such as low and medium bloom gelatins as natural adhesives, flocculants for wastewater treatment or microencapsulating agents, as well as collagen hydrolysates for fertilizers or functional additives such as retanning agents for the tanning industry. The developed enzymatic process to obtain biopolymers from PAPs within pilot ABP project constitutes a suitable and resource-efficient alternative to the conventional chemical treatment. This process allows a significant reduction in water and chemical consumption according to LCA analysis, as well as in processing time. In addition, no wastewater is produced, but is recovered instead as resource for fertilizers or biofuel. Within pilot ABP project, rendered animal proteins byproducts have been valorized through the transformation into added value products that can be reused by other industries, contributing to a circular economy model, as well as promoting the competitiveness of European industries. Pilot ABP project is co-funded by the European Union.